Welcome back, viewers. Today I want us to look at solids and nets. In question 2, a model of a drilling bit consists of a cube and a pyramid on a square base shown below. In Roman 1, draw an accurate net of the model 3 marks. In Roman 2, calculate the surface area of the model. And then finally, if the alloy used to make the model has a density of 25.85 grams per centimeters cubed, find the cost of 1 kg of the model if it retails at 2,500 shillings per kilogram, 5 marks. So what we're going to do first is to make a sketch of the net of this particular model. So when we open up this model, what net are we going to get? If we make a sketch, we are going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, 5 similar faces of the cube and 4 similar faces of the triangles. So it depends with how you're going to open it, but for my case, I opened it in this particular manner, so that we're going to have something like this. So we have 1, 2, 3, 4, 5 faces of the cube and 4 faces of the triangles, like that. So it is important that you make a sketch so that you know where you are heading to. And on this net, this will be 3, 3, side 3 by 3, 3, 3, and then these triangles 4, 4, 4, 4, like that. And then this is 3, this is also 3. So that is what we want to construct. So getting to the space provided by the examiner, you can get your ruler now and pair of compass, because we want to make an accurate drawing of the same. So we can start by drawing a horizontal line. Of course, you have an option of also picking a convenient scale if the diagram might be too large for the space provided. So we start by drawing horizontal line, like that. and then measure off 3 centimeters from your ruler. Measure off 3 centimeters from your ruler. Strike an arc like that. And then we can as well strike an arc on top and also an arc on bottom. From those points, and then we can erect a perpendicular from one of the points here, like that, and then draw a line through. Like that. Take your set square using the slide rule method. Draw the vertical line through the other point. Like that. So again, draw the horizontal line. To complete your square at the bottom, and draw another horizontal line to complete your square at the top. So we have two squares, and we need to get another square to the right and to the left of the middle one. We're going to treat this as a middle square, so we get another square to the left and another one to the right. So to get this one is easy. We come and draw using slide rule another parallel line on top here. We can extend this line like that, and then with a measurement of 3 centimeters from your ruler. Step here, strike an arc on that line, and another arc here on this line. Again to the right, step here, strike an arc, and here strike another arc. Using slide rule again, join or draw a vertical line through those points. Like that. And through this point. Like this. After that, we need another square on top. You can extend this line here. Measure of 3 centimeters. Here 3 centimeters. And you can join this point because they are equal and parallel. You can join them using a straight line. Like that. Now what we need to do, we have the 5 faces, 1, 2, 3, 4, 5. We need to draw the triangular faces, which are with a slant height of 4 centimeters. So measure 4 centimeters from your ruler. Step at this point. Strike an arc here. Step at this other point. Strike an arc. Do the same to the point at the bottom. Strike an arc here. And another arc to cut this one. The other point as well. Strike an arc here. And another point there. And finally at the top, strike an arc there. And another one to cut this. And finally join these points. Like that. You will have now completed your accurate net. So that is the required net of that drilling bit. So that is the accurate diagram of the required net. And of course, this is 3 by 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 3, 3, that is 4, 4, 3, this is 4, this is 4, and this is 3, 3, like that. Now the first question, we're told to calculate the surface area of the model. Calculate the surface area of the model. Now to calculate the surface area of the model, we are going to get, this is now Roman 2, surface area will be given by the area of the 5 faces of the cube plus the area of the 4 faces of the triangle. Area of the 5 faces of the cube, area of the cube, faces of the cube, plus the area of the faces of the triangles, like that. So the area of one face of the cube is given by 3 multiplied by 3 multiplied by 5. So this will be 3 multiplied by 3, that is the area of one face, which is 9 multiplied by 5, which now gives you 45 centimeters squared plus the area of the faces of the triangle. So if you consider one triangle, we have got a triangle with a base of 3 and a slant height of 4. So we can get the height of this triangle. We can get the height here, so that this becomes 1.5, 1.5. And the height, using Pythagoras theorem, height will be given by the square root of 4 squared minus 1.5 squared. So the square root of 16 this gives you the square root of 16 minus 2.25. The square root of 16 minus 2.25. So the square root of 13.75, which is approximately equal to 3.71. So the area now will be given by half times the base is 3 times 3.71 times 4, which is approximately equal to half times 3 times 3.71 times 4, which is approximately equal to, can confirm this, 22.26. So the total surface area will be given by 45 plus 22.26, which is approximately equal to 67.26 centimeters squared. 67.26 centimeters squared. And then in the next question, you're told to calculate the cost of making this drilling bit if the alloy has a density of 25.85 grams per centimeters cubed, and 1 kg would go for 2,500 shillings. So in part 3, first what we need to do, we need to get the volume of the model. The volume of the model in part 3 will be given by the volume of the cube, the volume of the cube plus the volume of the pyramid on top. The volume of the pyramid on top. And the volume of the cube will be given by 3 multiplied by 3 multiplied by 3, which gives us 27 centimeters cubed. The volume of the pyramid, we now need to get the volume of the pyramid, and in this particular case, for us to get the volume of the pyramid, we have to consider this diagram here. This is 4, this is 4, and this is 4. This is 3, and this is 3. We have to get the vertical height of the pyramid by first of all getting the diagonal of this pyramid, so that from the vertex V we get this particular height here, h. So using Pythagoras theorem, the diagonal, if I call this AB, the diagonal AB is given by the square root of 3 squared plus 3 squared is the same as the square root of 8. This is 9 plus 9, the square root of 18, which is approximately equal to square root of 18, 4.24. 4.24 divided by 2, because we want to get the midpoint, up to the midpoint here. When you divide this by 2, you get 2.12. 2.12. Therefore, we're now going to consider this triangle. This slant height here is 4. This height we do not know, and then this base here is 2.12. Again, using Pythagoras theorem, h will be given by the square root of 4 squared minus 2.12 squared. So this is the same as the square root of 16 minus 4.49. So the square root of 11.51 which is approximately equal to 3.39. Therefore, the volume of the pyramid now will be given by a third times the base area, 3 times 3 times the height, 3.39. So you can simplify that using your calculator. That will give you 3 cancels out here. 3 times 3.39, that gives you 10.17. So the total volume will be given by 27 plus 10.17, which gives you 37.17 centimeters cubed. Now the density, we are told that the density 1 gram or 1 centimeter cubed has got a weight of 25.85 grams. So 1 centimeter cubed has a weight of 25.85 grams. One centimeter cubed is equivalent to 25.85 grams. What about 37.17 centimeters cubed? So when we cross multiply, we'll get 37.17 multiplied by 25.85. That gives you 960.84. But we can easily work out this by dividing by 1,000, so that we can convert this into kilograms and again multiply through by 2,500 to get that particular cost. So we are saying to get the cost of 1 kg, we are going to get 37.17 multiplied by 25.85 divided by 1,000. Why 1,000? Because 1,000 grams make 1 kilogram. So once we've converted this into kgs, we shall come and again multiply this by 2,500, and this will give you an approximate cost of, when you divide or you work out that using your calculator, confirm to see whether you're going to get 2,402 to the nearest Kenyan shillings. So approximately equal to Kenyan shillings 2,402 per kilogram. So that is how you ought to work such a question. Thank you for watching. Kindly like, subscribe and share.